Hey guys, it's Mr. Bicen here, and we're going to be continuing with every exam question that's ever been asked, and we're going to be looking at the cumulative frequency and box plot section, which we've got here, and we're actually just going to start off with the beginning section, which is just going to be quartiles and box plots. At the end, cumulative frequency diagrams, that's going to overlap with some of the other ones, so we will just get started right away with this. Okay, so for the part that we've got here, it says, from a non-calculator paper, the topic is quartiles. A bus company recorded the ages and years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. Complete the table below to show the information about the ages of the people on coach A. Well, they've already done the least age for us and they've done the greatest age, so we're just going to find the median and the quartiles. Now, you could do like the crossing off from either end, or you could try and use a kind of shorter method for this. So for the median, what we're going to do is we're going to add one on to the number of people. Because it's in a list, we do need to add one onto this. So it's going to be 23 plus 1, and we'll half it to find out the middle. So that's going to be the 24 over 2. That is the 12th position. So I'm going to go 1, 2, hang on a second. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the median is 59. Now the lower quartile is going to be halfway along this group of numbers. So you could also do the crossing off kind of thing, or if you want to, for the lower quartile, we could do 23 plus 1. If we divide it by 4 for the lower quartile, because it's a quarter of the way, that's going to give us the 6th position. Now the 6th position, 1, 2, 3, 4, 5, 6, that is 53. And then the upper quartile, unsurprisingly, if it goes the 6th, then the 12th, the upper quartile is 3/4 of the way along, so it's going to be the 18th. Now, you can actually spot if that's the 12th, 13, 14, 15, 16, 17, 18th, like that. So your quartiles, your lower quartile is 53 and your upper quartile is 66. So it says here, for the first part, it says, I don't know why I've got 4 marks here. I need to change that. It should just say that it's 2 marks for this bit, and then these are 1 mark each. It says, here is some information about the ages of the people on coach B. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? You must give a reason for your answer. So the best measure, just to tell like the average age, is to have a look at the median. So we've got the median of both of these different coaches. And so Richard says that coach A is younger than coach B. So he's right, because the median is lower. So for part B, is Richard correct? I'm going to say yes. The median age for A is 59, which is lower than 70. And you're going to start seeing the kind of similar patterns in these questions, because we're now going to compare something else. It says, Richard says that the people on coach A vary more in age than the people on coach B. So this was about median. This is now going to be comparing either the range or the interquartile range. So I don't know, it doesn't really matter which one you're going to do here, but if I find out for coach A, I'm going to find out what the interquartile range is. So the interquartile range is the upper quartile, take away the lower quartile, and 66 take away 53 is 13. And then for coach B, the interquartile range is the upper quartile, take away the lower quartile, and that is going to be 19 for that. Yep, that's right. So we just need to say, Richard says that they vary more in age than the people on coach B. Well, actually, Richard is wrong, because the interquartile range here is larger. So I'm going to say, no, Richard is wrong. The interquartile range for B is larger than A. In other words, they vary more. So B varies more than A. Let's see if we've got these right. So we've got the 59, the 53, and the 66, and then we've got yes with a reason and no with a reason. So here are some of the like accepted kinds of things. They really do want you to have numbers with these bits. Like I said, you could do it with the interquartile range, but they also would have accepted answers with the range as well. Okay, this question that we've got here, we've got the box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. Work out the interquartile range for the amounts of money spent by these male students. So we're going to just quickly look at some of these values that we've got here. I would say that this value that we've got is exactly halfway between 100 and 200. So the lower quartile, that is 150. And then I'm going to also have a look at the upper quartile. This looks a little bit trickier to see. So if each of these blocks are worth 20, a little half block is 30. So I think that that is 330. So when I just zoom back out for this, it says work out the interquartile range. So our interquartile range, that is the upper quartile, 330, minus the lower quartile, which is 150. So the interquartile range is £180. The table below shows some information about the distribution of the amounts of money spent by some female students on their holidays. Draw a box plot that we've got here. So the smallest we want to put at 60. I'm going to do it in a blue colour as well. So the smallest is going to be at 60. So I'm going to say that 60 is 3 squares from the end like this. The lower quartile is 180. So each square is worth 20. So that's going to be 180. We've got the median is 300. We've got the upper quartile is 350, so that's going to be halfway along these boxes. And then the largest value is 650, which is going to be all the way over here. Now, to draw the box plot, we simply connect those 3 bits together, not with a curved line like I've just done, but like a straight line like this. And then we just connect these bits to the end like this. So we've got our box plot that is drawn there, and then it says for the last part, Chris says the box plot shows that the female student spent more money than the male student. Is Chris correct? So whenever you're wanting to do a comparison of these kinds of things, the best thing is not to think about the range or the interquartile range, but it's literally just going to be thinking about one measure, which is going to be the median. So if we compare the median for these things, we can explain this. So we can say, is Chris correct? We are going to say yes, the median for females is higher than males. The median for females is higher than for males. And we can just show that because we know the median is 300 versus, what's that, 250. So 300 is greater than 250. Okay, let's see if we've got this right. So we want 180, and then we've got the box plot, and then the median's 250 and 300. So we do want to kind of give some numbers with that as well. Okay, this time we've been given the least height, the median, the lower quartile, but not the upper quartile. We've been given the interquartile range, and these are about some heights of some year 11 girls. They've also told us the range as well, so they haven't told us the upper quartile or the highest value. So we want to draw a box plot for this. Well, I'll start off doing the values that we know about. We're going to do the 154 for the least height that we've got. So 154 is going to be here. And then the median is 100. Oh, so we'll do the lower quartile next, which is 161. So we'll do 161. Let's make it a nice straight line here. And then we've got that the median is 165. Now we need to find out what the upper quartile is. So if the interquartile range is 7, that means that the upper quartile is going to be the lower quartile plus 7. So the lower quartile plus 7, that's 161 plus 7. It is 168 for the upper quartile. So I'm going to go and draw in a line here. And then our highest value that we're going to get, well, the highest value is simply going to be the lowest value plus the range. So the highest, or the most height, the highest height, that is going to be the least height, which is 154, plus the range. So that is 174. Because if you remember, the range is the biggest, take away the smallest. So I'm going to go to 174, and I'm going to draw a line in here. As you know, with box plots, the middle section, which is the middle 50%, that's going to be a box, and then we just kind of join these two parts like this. So we've now got a different box plot, and it says the box plot below shows information about the heights in centimetres of a group of Year 7 girls. Compare the distribution of heights of the Year 7 girls with the distribution of heights of the Year 10 girls. So I'll do this as my part B of the question. Now, when you do a compare question, there are two things that you need to compare. You need to compare the spread, and you need to compare the location. Now, what I mean by the spread, I mean the spread is either the range, or, not the ranger, but the range, or the interquartile range. And the location, if it's from a box plot, just means the median. It's just like which one is higher. So I'm going to do a comparison, and as the first bit of comparison, I'm going to say that the Year 11 girls are taller because their median is higher. So the Year 11s have a higher median height, Now you don't need to say this next bit, but it's good to have. Year 11s have a higher median height, so they are taller on average. they are taller on average. That's our first mark that we've got here. And then we need to compare the interquartile range or the range. I think it's kind of easier, I think, in this case to compare the interquartile range. We can see that the interquartile range, how wide that box is smaller than this one. So we can say that the interquartile range for year 11 is smaller than for year 7. Now, you don't need to explain this bit, but you can actually just mean that that is that the data for year 7 is more closely packed together. But as long as this one is in context, as long as as long as one out of the two of them are in context, you're going to get the mark. So we've got the box plot drawn with our extra bits of information here, and then a comparison of the median, a comparison of the spread, and it says for the award of both marks, at least one comparison must be made in context. What I mean by context there is just the height, really, saying it's in centimetres or height. Okay, pretty straightforward. We're just going to draw a box plot, and then we're going to do an estimate for the second part of the question. So the least height is 133. So I'm going to draw a line here for 133. The greatest height is 170. We're going to say that the lower quartile is 145. The upper quartile is 157. I hope I don't make any mistakes doing this. And the median is 151. As usual, make this into a box. Hopefully it won't be as wonky as my one, but that's not a problem. But you definitely get all the marks for this. So it says here, work out an estimate for the number of these girls with a height between 133 and 157. So 133 happens to be at the lower quartile, at the lowest value, and 157 happens to be here, which is at the upper quartile. Now, each of these sections represents 25%, or they represent a quarter. So this is a 25% section, this is a 25% section, this is a 25% section, and this is a 25% section. So 75% of them we would estimate to be between 133 and 157. So all I want to do for part B of the question is I want to find out 75% of the number of girls that there are, which is 80. Completely jumped around, I don't know why that went all the way over there. 75% of 80, which is the same thing as finding 3/4 of 80. It's probably how my mind would do this. So I would do 80 divided by 4 to find out 1/4, which is 20, and then 20 multiplied by 3 to get my answer of 60 for this bit. So the box plot was just going to be what we've got drawn here, and then we've got 60 for this bit. Okay, we've got one from a calculator paper. I don't think we're going to need it, but it says Megan grows potatoes. The box plot shows the information about the weights of Megan's potatoes. Megan says that half of her potatoes weigh less than 50 grams. Is Megan correct? Well, she's not, because we know that each of these sections represents a quarter. So actually half of her potatoes weigh less than 57. So is she correct? No. And we're going to say half weigh less, not weigh, half weigh less than 57, which is the median, not 50. And then it says Amy also grows potatoes. The box plot shows the information about the weights of Amy's potatoes. We've got Megan's and Amy's. Compare the distribution of the weights of Megan's with the distributions of Amy. So remember, we do two comparisons and one of them needs to be in context. So we can say that, and if you look at the scales are exactly the same. So I'm going to say here, if we just look at the medians to begin with, Megan has got a higher median, which means her potatoes weigh more. So I'm going to say that the median weight, and as soon as I say the word weight, that's putting it in context. The median weight of Megan's potatoes, is higher than Amy's, And I'm just going to also put some numbers in there just to make sure that I've got it right. I'm going to say that 57 is greater than 42. And I'm going to also say that this time I'm going to say the interquartile range, because we can see this box is bigger than this box. So I'm going to say the interquartile range of, who's got the larger one, of Amy's, or Megan's, sorry. The interquartile range of Megan's potatoes is larger than Amy's. And I don't think we need to put some numbers in with this, but if we did want to put some numbers, we can see this is 65 and 39. So what's that? That's 15, 25, 26, because 26 is greater than, if we look down here, it's going from 35, 15 is greater than 16, 26 is greater than 16, but I don't think we need to have those numbers. We'll see what it says though. So we'll see the first part. Yeah, no, the median is 57, and they have actually got some numbers here. Let's just double check and see if we need to include them. So it says simply quoting values is insufficient, but they may be compared. Figures given must be correct. I don't think they actually need to be given. For the award of both marks 1, the comparisons must be in the context. So no, I don't think we even need the numbers, but if you do put them, it's not the worst thing that you could do. Okay, Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in this table. She drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things that she should do to make the box plot correct. So first of all, the least height is 142. Well, that's in the right place, so I'm going to tick it. The lower quartile is 154. That's in the right place, so I'm going to tick it. Now, the interquartile range is 17. That would mean that the upper quartile is the lower quartile plus the interquartile range. So I'll do 154 plus 17, 154 plus 17. The upper quartile is 171. So actually, the upper quartile is in the wrong place. So I'm going to say that the 2 things that she should do, the upper quartile should be changed to 171. Should be changed to 171. Not 172 that it currently is. The median is 162, and that's actually at 161, so that thing is wrong. So I'm also going to say the median should be at 162, not 161. The median should be changed to 161, 162, not 161. And the last part is actually correct for the range because it's going from 142 to 182. So these are the 2 things that could be said here for those 2 marks. Let's double check we've got them. Yeah, the median should be at 162, not 161, and the upper quartile should be at 171, not 172. Okay, this time we've got lots of different things kind of going on in this question. It says the box plot shows the information about the length of time in minutes. Some people waited to see a doctor at a hospital on Monday. Work out the interquartile range in the box plot. So I'll zoom in just to make this a little bit easier for us to see. I would say that being careful of the scale here is the most important bit. So that's going to be halfway between 40 and 80. So that's 60. That must mean that the lower quartile is equal to 50 here. And then the upper quartile, this is 180. Now, if it's going from 180 to 200, that's a gap of 20. So each of these 5 squares must be worth 4. So it would go 4, 8, 12, 16, 20. So if this is 180 and each square is 4, that means that the upper quartile is 188. They're really kind of testing your skills at being able to read these things. So the interquartile range is just going to be 188, take away 50. Obviously, you could put it on a calculator. That is going to be 138 when you subtract the 50. Becky says 50% of the people waited at least 2 hours. Is Becky correct? Well, 2 hours, obviously we know that 2 hours is 120 minutes. And if we look at 120 minutes on the box plot, we can see that it is actually at the 50% point. So this is 50% here. Becky says 50% of the people waited for at least 2 hours. Is Becky correct? And we can just say yes, the median is 120 minutes. Is 120 minutes or 2 hours. Okay, then it says the table gives information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. Becky was asked to compare the distribution of the lengths of times people waited on Monday with those on Tuesday. She wrote that people had to wait longer on Tuesday than on Monday. Give 1 reason why Becky may be wrong. Well, she said that people had to wait longer on Tuesday than on Monday. And I think as a comparison here, it's always best to do the medians for these kinds of thing. And I think we said that the median was 120. So it looks like people are actually waiting longer on Monday than they are on Tuesday. So I'm going to say give 1 reason why Becky may be wrong, and that is because the median on Monday, or the median on Tuesday, is actually lower than on Monday. The median on Tuesday is lower than on Monday. Okay, let's see if we've got these. So we're looking for 138, the median is 120, and then this little bit down here. So we've got 138, yes, because the median is at 2 hours, and the median is lower on Tuesday, and it's higher on Monday. Okay, one more, I think, on box plots, and then we're moving on to cumulative frequency graphs. This time it's from a stem and leaf diagram, so you need to make sure you understand these diagrams. It says the stem and leaf diagram shows the information about the heights in centimetres of 23 sunflowers. On the grid, draw a box plot for this. Okay, so let's get the key values that we need. We need the lowest, which is clearly 173. There it is. The highest is this 9, which goes with the 21, so it is the 219. So the highest is 219. Now we're going to try and figure out the median and then the lower quartile and the upper quartile. Now there's no surprise they've done 23, because if you do, for the median, if you do 23 plus 1 and divide it by 2, that gives you 24 divided by 2, or the 12th number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that 7, which corresponds to the 197, is the median. Now the lower quartile, that is 23 plus 1 divided by 4, that's going to be the 6th position. So they've used this 23 because when you add 1 and divide by 2 and 4, you get nice numbers. So the 6th number is going to be 1, 2, 3, 4, 5, 6. It's going to be 188. I'll do that in a different colour so it's clear where it comes from. So the lower quartile is 188. Now the last one for us to do is the upper quartile, which is 23 plus 1 divided by 4. And because it's 3/4, we times it by 3. Well, the first part we know is 6, times that by 3, and we get the 18th position. So I'll do the 18th position. Well, that's 12, 13, 14, 15, 16, 17, 18. So it's the 9, which is going to go with the 20. So the upper quartile is 209. All we need to do now is to draw this on the diagram. So I'm going to just use these values that we've got here. I'm going to do the 173 for my lowest value. Then I've got my highest is 219 all the way over here. The lower quartile is 188. The median is 197. And the upper quartile is 209. I'll join this middle section together like a box, add those two little bits on at the end, and we've got a box and whisker diagram. Well, not box and whisker diagram, that's what we used to call it years ago. A box plot that we've got here, and that's for 3 marks. So we'll just double check and see we've got the right values. We've got the lower quartile was 188, the median was 197, the upper quartile was 209, perfect. And then we did have our lowest and upper values, and that's our box plot done. So in the next video, I'm going to be continuing and I'm going to be doing stuff to do with cumulative frequency graphs, and those then start overlapping with box plots towards the end.